Welcome to Lesson 4, Trends in Ionization Energy. Our lesson objectives describe the trend in ionization energy across a period and going down a group, and explain why these trends exist. Ionization energy is the energy required to ionize or remove the most loosely bound electron in the valence shell. Putting another way, it's the amount of energy required to remove an electron. The values are located on table S, just like atomic radius, in this column here, and it says first ionization energy, the energy required to remove the first electron from the valence shell, and our units are in kilojoules per mole. So what are our trends that exist on the periodic table? Well, when we go across a period, we're going to see a general increase in ionization energy, meaning it takes more and more energy to remove an electron from an atom as we go across a period. Why? Because as we go across a period, we have greater proton or nuclear pull. More positive charge pulling those negative electrons in, which makes it more and more difficult to remove electrons. So if we look at period 3, let's look at aluminum versus chlorine. As we can see here, aluminum has 13 protons or 13 positive charges in the nucleus, and chlorine has 17. So in comparison, chlorine has a stronger nuclear pull, which means it's pulling on these electrons more and it's holding them tighter. And so therefore it takes more energy to remove an electron from chlorine due to that stronger pull than it does aluminum. And so the ionization energy, the energy required to ionize it, remove this electron, is greater. What are the trends then in ionization energy going down a group? When we go down a group, we're going to see a general decrease in the ionization energy. So it takes less and less energy to remove an electron. Why? This is due to the fact that the atomic radius gets larger as we go down, and so that nuclear pull is felt less and less on the outer electrons, as we can see here. So going down a group, the atom is going to get larger. So in a smaller atom, the nuclear pull, the positive charge, is felt much more on the outer valence electrons. When the atom gets larger, that pull is not felt as much on the outer electrons, and therefore it's easier to remove an electron from them than it is the smaller atom. So let's see an example. What is the trend in ionization energy going down a group? And the answer is decreasing. Why does that trend occur? As we just said, due to more electron shells. So how do we determine the trend in ionization energy instead of just memorizing it? Well, we can use table S to our advantage, just like we did in our previous lesson on atomic radius. So if we ask, what is the trend in ionization energy going down a group? What you can do is you can pick one element near the top of the group and one near the bottom, and then we can look up those values on table S and determine the trend. So using group 1, if you look at, for example, sodium towards the top, the ionization energy is 496 kilojoules per mole. Potassium, as we go down, is 419, and at the bottom here, rubidium is 403. So we see a general decrease in our ionization energy, so the trend is decreasing. What is causing that trend? The larger atomic radius due to more electron shells and less proton pull on the valence electrons. So let's check your understanding. Can you describe the trend in ionization energy going across a period and down a group? And can you explain why these trends exist? At this point, you should be able to describe the trend in ionization energy going across a period and down a group and explain why these trends exist.